Okay, so tonight we're talking about writing linear equations from a graph, and what we're doing this unit is actually working completely backwards from last unit. So you need to know how to do that before you can do this, just like everything else we've done so far. So make sure that you go ahead and add your date and your page number for today. And you go ahead and you write down your learning target and all that fun stuff. The next slide is where we talk about all the old forms, point slope form, or all the three different forms that you can write a linear equation. What you've done in the past is you've been given an equation in one of these three forms and you have graphed it. So we are basically working backwards. And the first one we're going to talk about is point slope form. Remember, it's y minus y1, which is the y value of your first point, or any point, and equals m, the slope, times x minus x1, where x1 is the x value of your point. If you need to pause this and write these down, do so, but you should have them and be aware of them already. So x1, y1 is a point, and m is your slope. The second one, which is the one that you're the most used to, is this slope-intercept form. It's y equals mx plus b. And in this form, notice y is by itself on the left side. This is the only form that this happens. M is your slope, and b is your y-intercept. It's actually the point 0b because it's a y-intercept and it sits on the y-axis. The last one, the newest one, is standard form. You were given equations in standard form and had to rewrite them in slope-intercept form and graph them that way. So standard form looks like this. The x and the y are on the same side. And then I made a little note, and you're probably going to need to do that as well. A, b, and c, these two coefficients, and this constant back here are integers. And you may need to make yourself a note about what that meant. At the beginning of the year, we talked about sets of numbers, and integers were positive and negative whole numbers, meaning that we can't have any fractions or decimals in this form. Okay, they all have to be positive and negative whole numbers. So if you need to pause it, write this down, jot yourself some notes, do so. Alright, so let's look at example 1. And in point slope form, that's the one we're going to start with. You're going to write the equation that represents this line. Okay, and I already plotted a point for you, but it doesn't matter. You can use any point. See where it crosses here, 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 here. You can use any point on that line, and it doesn't matter which one you want to use. So we're going to use the one that was already on your graph, this one. And this is the point 4, negative 5. And we're going to use this point as our x1, y1. Because in point slope form, we're going to just go ahead and write out the skeleton of it and then fill in our values as we go. So for every point slope form, you've got a y. And you've got a y minus whatever your y value is, so I'm going to leave a blank, equals m. That's your slope, so whatever your slope is. And then in parentheses times x minus, you always have this, and then you're looking for your x value here. So we're going to plug in the information for this specific line. So we're using this point x1, y1. So instead of x1, I'm putting a 4. And instead of y1, I'm putting a negative 5. Now the only piece of information I'm missing is my slope, my m. And if you look, this line is falling from left to right. So my slope will have to be negative. And if I count what my slope does between each of these points, it goes down 2, right 1. Down 2, right 1. Down 2, right 1. So my slope is negative 2 over 1. This isn't quite right yet. We can simplify this a little bit. You don't ever want to leave minus and negative, so we're going to clean this up before we finalize our point slope form. Minus and negative is the same thing as plus positive, so this is actually y plus 5. And then negative 2 divided by 1, let's go ahead and write that as the whole number negative 2 because that's the simplest way to write that. And then x minus 4 is just x minus 4. So that is my final answer of my equation of this line in point slope form. form. The next thing I need to do would be to write this in slope-intercept form. And if you remember, that's the y equals mx plus b. Notice the difference between this form and that form is that the y is by itself. So really all I have to do is take the equation that I've already found in point-slope form and rewrite it so it fits the criteria that I need. And it looks like I want it to. So if I was to rewrite this equation, remember y is by itself in slope-intercept form, so I'm basically solving an equation for y. Okay, well if you remember when we solved equations, the first step is if you can distribute, you should. So my first step is actually going to be to distribute negative 2. Negative 2 times x is negative 2x. And negative 2 times negative 4 is a positive 8. And then on this side I haven't touched y plus 5, so I'm going to leave it. I can't combine like terms on either side, and my variables aren't on the same side, but I don't have similar variables anyway. So I'm going to try to get y by itself, which means I need to get rid of plus 5. And in order to get rid of plus 5, I should subtract 5 from both sides. When I do that, I'm left with only y on this side, which is what I wanted. And then notice that I subtract the 5 from the 8 and not the negative 2x. The reason I did that is because these two are not like terms, however 8 and negative 5 are. So the negative 2x just comes down, and then 8 minus 5 is positive 3. So this is my equation of my line in slope-intercept form. This is the slope, and this is the y-intercept. And look at that. It is my y-intercept. It's where it's crossing the y-axis. Okay, and you could have actually been able to tell that just from looking at the graph. Okay, the last one is standard form. And this is the one that, if you remember, can't have any fractions in it. So I'm going to go from slope-intercept now to standard form. So it's going to start like it was in slope-intercept form and move it to standard form. So in standard form, the x and the y are on the same side, and there's no fractions. This time I have no fractions, so I have nothing to worry about. I don't have to get rid of anything. But I do need to move this negative 2x to the other side. So in order to move, remember, negative 2x to the other side, I would have to add 2x. And those aren't like terms over here on the left side, so I'm just going to combine them. And in standard form, the x comes before the y. So it would be a positive 2x plus 1y, and you don't have to put the 1 if you don't want to, equals the only thing left on the right side was 3. And that is your final answer in standard form. We're going to try one more example, same thing. So we're starting in point slope. And we're starting in point slope because this is the easiest one to write it in. So I've got y minus, remember I'm making my little skeleton that I'll fill in later, m times x minus whatever x1 is. So I'm going to pick any point on here. I'm going to pick, let's do this point right here where it crosses. And I'm going to use that point negative 3, negative 9 as my x1, y1. Okay. So when I go to fill that in, y1 is negative 9, x1 is negative 3, and my slope now, I have to count between points. So there's points here, 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 and if I count, notice that it's rising. So this time my slope is positive, and from there I'm going to go up 2, right 3. So my slope, my rise over run, because I go up 2, right 3 every time, would be 2 over 3, or 2/3. So again, we're going to clean this up a little bit. Minus negative 9 is the same thing as plus 9. 2/3 is just 2/3. And then minus negative 3 is the same thing as plus 3. So point slope form, there is my answer. Okay. Now we're going to go from that to slope-intercept. And that was the y equals mx plus b. And remember, we're starting from point slope and moving to slope-intercept. So if I was to do that, I have to try to get y by itself. So I'm just solving an equation. First step in solving an equation is to distribute 2/3 times x. And I get 2/3 x. And then 2/3 times 3 is 2. And then on the other side, I didn't touch the y plus 9, so it stays the same. Next step to get y by itself would be to move 9 to the other side. So when I move 9, I have to subtract it, and I subtract it from the 2, because again, those are the like terms, not the 2/3 x. And I'm left with y equals 2/3 x minus 7. And that is my equation in slope-intercept form. And again, you could have just used the graph to see that it crosses at -7 and that the slope is 2/3. The last one is standard form. Standard form is that ax plus by equals c, and again, I can't have any fractions. Well, in this case, I do have fractions when I start in slope-intercept form, or any form for that matter. So I've got to get rid of it. So my first step should be to get rid of my fraction. And the easiest way to get rid of any fraction is to multiply everything by the denominator. So if I want to get rid of the 3 on the bottom, see how this is being divided by 3, it's 2 divided by 3. To get rid of that, you would multiply everything by 3. So I would do 3 times y, this times 3, this times 3. So when I do that, I get 3y equals 2x, because those will just cancel. That was the whole point in doing it. Minus 7 times 3, which is -21. I still don't have all my variables on the same side, or I still don't have my x on the other side, so I'm going to need to move it. And in order to move it, I would subtract 2x, subtract 2x. Again, these are not like terms, so I can't combine them together, which you shouldn't, because in standard form, it's something x plus something y equals c, or the constant. So I'm going to move it, and I'm just going to put the -2x in front of the 3y, because in standard form the x comes first. And the only thing left over here is -21, and that is the equation in standard form.